Okay, so the reactions that involve will be, the first one is the formation of halogen alkenes. Okay, formation of halogen-alkenes. There are three ways that you can form halogen-alkenes or haloalkenes. Okay, first, so you see this is the connection between. Uh, a few days ago, you learned about haloalkenes, right? And then from haloalkenes, you can form alcohol. Can you? Can you form haloalkenes from haloalkenes to form alcohol? Can or not?
Yes.
Don't remember anymore.
Yes.
How?
Yes, yes.
How?
Substitution.
What kind of substitution?
Cool.
Nucleophilic.
Nucleophilic.
Potassium.
Nucleo
Nucleophilic.
nucleophilic
What do you?
salt.
What is the reagent?
Cool.
Um,
Potassium iodide.
Hmm? Hmm. Huh? What happened?
Potassium permanganate.
Potassium manganate. Potassium manganate. Haloalkanes. Potassium manganate. Haloalkanes, eh? You're talking about haloalkanes. Potassium manganate.
Hydroxide ion.
That is oxidation. It's potassium manganate.
Aqueous sodium hydroxide.
Aqueous
Yes, aqueous sodium hydroxide. Okay, that is your reagent. What is the condition? Aqueous sodium hydroxide.
heated under reflux.
Under reflux. Okay, so then that is substitution reaction. Okay, don't just say substitution. My question is, how do you get from haloalkanes to form alcohol? So you have to mention what is the reagent. You cannot just say, okay, substitution reaction. No, 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 no. That is not the way that you learn organic. Okay. All right. So in this case, you can form back from alcohol. You can form back your haloalkanes. Okay, so there are three ways that you can form haloalkanes. First one is by using hydrogen halides. Okay, and the second one is for you to use the phosphorus halides, whether you can use PX3 or PX5. The X is the halides lah, of course. And the other one is thionyl chloride. Okay, so you can use either one of these three with a certain condition that you are going to look at later on, right? And then the next reaction is the dehydration of alcohols. Dehydration meaning?
Remove water. Yeah.
Yes, removing of water. Okay, so removing of water from alcohol meaning you are going to get alkene. Okay, you are going to get alkene. All right. Okay, so let's look at the first reaction, the formation of haloalkanes. Okay, so basically you're not going to learn in detail the mechanism, but it's just for you to understand that this is a nucleophilic substitution reactions, because in the alcohol we have this carbon as a very positively polarized. Okay, very positively polarized, and O here is negatively polarized. So what will happen? This is your nucleophile, the one that you are going to replace. Okay, so what will happen? Nucleophile will attack to this carbon. Okay, so that's why it is named as nucleophilic substitution, because you are going to put this one is going, the nucleophile will attack the carbon and this one will be leaving. OH is the leaving group. So what will happen? It will be replaced with this X. Okay, the X will be formed. Okay, so let's look at, I'm not going to talk about the mechanism as I said, because you're not it is not in the syllabus pun. Okay, but just so that you will understand, this is nucleophilic substitution reaction. Okay, so the first one is hydrogen halides, for you to get the haloalkane by using hydrogen halides. So let's see the general equation, for the alcohol and hydrogen halides. So you should get very simple, OH replaced with X, and you get your byproduct is water. Okay, an example here, Very easy. Propanol, 1 propanol. You have HCl and then just substitute Cl with OH. Then you get that lah. Very simple. You don't have to know the mechanism pun.
Aku memang yang kutu aku semua bukan respon. Kutu aku tak respon lagi. Dia ada
Alright.
benda yang utama. kena
Okay,
respon.
done.
Yang smart.
Okay, so what is the condition? You must use concentrated hydrochloric acid if you are using hydrochloric acid lah. Okay, because the most common hydrogen halides that we use is hydrogen chloride. So we are using concentrated hydrogen chloride at room temperature. So you just add the two of them and you get your haloalkanes and water. The byproduct.
Alright.
Okay.
Okay.
Alright, the next one, the second way of you to form haloalkanes is by using phosphorus halides. So you can use PX3 or PX5. Usually we use PCl3 or PCl5. But when you use PCl3, the observation will be different. When you use PCl5, the observation will be different. So let's look at the reactions, and the condition is just simple at room temperature only. So with PCl3, this is an example of the reactions. So you look at that, what you get is phosphorus acid. Okay, not phosphoric acid because it has missing one oxygen there. If it is phosphoric acid, it will be H3PO4 kan?
Yes.
So this one, one oxygen is, so it is phosphorus acid. Okay, so this is by using PCl3. Alright, when you are using PCl5, usually when we want to test for the presence of OH group, we use PCl5 instead of PCl3 because PCl3 the observation is not very clear. Okay, so that's why we use PCl5 to be used as a test for the OH group because the observation and the reaction is very violent. Okay, with PCl5, and then the observation is to it will produce clouds of hydrogen chloride. Remember?
Yeah. Vapor.
White fumes kan? White fumes. Yes. You can say clouds of hydrogen chloride gas, or you can say white fumes. Yes, white fumes. Okay, producing white fumes. So this is the equation. Here there is no HCl, right? So that's why we seldom use PCl3 for the test, the presence of OH group. So we always use PCl5 so that we can see that the presence of the white fumes there.
Dapat habis susu ke?
Okay.
Wait. So all this at room temperature, teacher.
Yes, room temperature. The condition, because at room temperature the PCl5 can react very violently. What more if you want to heat it up kan? So you don't need to heat up for the reaction to occur.
Okay.
Okay.
Alright.
Okay, so and the next one is for you to react with, another option is for you to react with thionyl chloride, or the not scientific name, this is the common name, thionyl chloride. This is the IUPAC name, sulfur dichloride oxide. Sulfur dichloride oxide, SOCl2, thionyl chloride. Okay, so this one is also at room temperature. As an example, it's very easy, and still it will produce HCl also. Okay, it's just that for this reaction it is not very favorable to be used because it will form SO2 and HCl, which is a very, very poisonous, can. HCl and then you add with the SO2, so that is a poisonous combination lah to these two. Okay. Done. Okay, next reaction is dehydration of alcohols. As we have mentioned just now, dehydration meaning remove water, elimination of water. So elimination meaning it will form alkene. What else? What other reactions can form alkene beside this alcohol? Before this, yeah, we learn.
Beside alcohol.
Yes.
Haloalkane.
Yes, haloalkane. What is the condition? What is the reagent that you have to use to get this elimination reaction with haloalkanes? Ethanol?
Ethanolic.
Ethanolic?
Sodium.
Yes, sodium hydroxide. Ethanolic sodium hydroxide. Then you will get, then you react with your substrate is your haloalkenes. Then you get your alkene. Okay. So these are the things that you have to remember. So you have to keep on go back. Okay, you have to go back and recall back whatever that you have learned before this. Each and every time you see something, so you have to refer back or you have to recall back whatever that you have learned before this. When we are talking about, let's say for example, alkene. So because there are some of the reagents cannot react with alcohol. Okay, so those are the things that you have to think of, right, in organic lah, for the organic reaction. So this dehydration of alcohols we can use, or we can have these two conditions, or we can do with these two methods. Okay, to eliminate water from alcohol to form alkene, we can use these two methods. Okay, the first one is to use concentrated sulfuric acid. By using concentrated sulfuric acid, so and we have to make sure that the sulfuric acid is in excess. And sulfuric acid, the function of sulfuric acid here is as the catalyst. Okay, it must be heated up to this temperature, and the gases produced are passed through sodium hydroxide to remove the carbon dioxide. The function of sodium hydroxide is not to react. This one is not to react, but it's just to remove the carbon dioxide that is formed from the equation, and the ethene will be collected over water. So in terms of the equation there, so maybe you don't see that there is the formation of carbon dioxide here, but then because this is the simplified equation that is more important rather than talk about the carbon dioxide and all those things. Okay, so this is the most important, the more important equation. When you have alcohol, you have concentrated sulfuric acid, this is your product, your main product. This is your byproduct. Byproduct is sometimes it's important, sometimes it's not important. So I usually forget that this byproduct when it is not. For example, the byproduct, when it is dehydration, definitely you should have a byproduct here, kan? So you don't have to memorize. When it is dehydration, definitely the water should be on the right side. So you get your alkene here from your alcohol. Okay. And ethene is in a form of gas. Ethene, when ethene is in a form of gas, so it's usually collected over water.
All right.
Okay. The others, can I move to the next?
Yes.
All right. So, okay, this is the second method for you to form alkene from alcohol by using aluminum oxide as catalyst. Just now, in the first method, you are using concentrated sulfuric acid as the catalyst. Okay. In this case, we are using aluminum oxide as the catalyst. So this is your aluminum oxide. This is small scale lah, small scale of producing your alkene here, ethene. Okay, so ethanol vapor is passed through. Ethanol vapor is passed over heated aluminum oxide powder. So this is the mineral wool, the wool, you know, the wool that we soak in water pula, in ethanol. Yeah, in ethanol. So that is your substrate, your ethanol substrate. So we pass it through here by heating up this aluminum oxide. So the gas that is formed, you get this one. The ethene will be collected here over water. This is a standard lab apparatus, because this one may be coming out in your paper 5. It may not come out in your paper 3, definitely not. But it may come out in your paper 5. Or it may also come out in your paper 2. Or it may come out in your paper 1. Okay, in terms of labeling and all that lah.
Teacher,
Yes.
if we use the sulfuric acid as the catalyst, is it the same setup apparatus like this one?
A little bit different, because the product, there will be a combination between water and also carbon dioxide. So it is something like sodium hydroxide will be in the U-tube. You know what is U-tube or not? Not the YouTube, the YouTube that you watch video tu. The YouTube tu. Okay. And then in that YouTube you put the sodium hydroxide, so it will be passing through that, and then only will be collected. So there will be like another one. It may be a little bit like this, okay? And then there will be one tube here, and then only will be collected over water like that. So one more apparatus lah here for sulfuric acid. And it will not be ethanol in soaked in like this lah, because there is no aluminum oxide, so it's just a mixture. The ethanol and also sulfuric acid are mixed, okay, and then the gas will be passing through the U-tube that has sodium hydroxide, and then it will be passing through here to get your ethene gas.
Oh,
Okay.
Sodium hydroxide.
Sodium hydroxide tadi. Ni. The gases produced are passed through sodium hydroxide to remove carbon dioxide if there is any carbon dioxide. This is the function of sodium hydroxide, to absorb carbon dioxide. Okay.
Kau tak boleh nak keluar. Anak saya keluar tak keluar. Oh, dia keluar. Itu masa makan. Pada dia nak kat sana. Panggil anak kau lalu mana kan. Betul. Dia panggil dia. Nak keluar.
Okay, done.
Then
Okay. Okay. Now this is quite important topic. Test for alcohol. Meaning test for alcohol. You have unknowns. You have unknowns, and then you have to test whether this is primary alcohol. First, you can test whether it is an alcohol or not. This Lucas test, for this one, the first test here, is the test to differentiate whether it is primary, secondary, or tertiary alcohol. Okay, and then another test, because you have learned yesterday, another test for primary, secondary, tertiary alcohol is by using, besides Lucas test here,
So,
what else can you use?
Collins.
No. Eh?
Fehling.
No, Welling is for aldehydes.
Tolerance.
No, tolerance is for aldehyde.
Potassium manganate.
Why potassium manganate?
Different products for different types of alcohols.
How do you know potassium manganate? Should it be potassium manganate or potassium dichromate?
Okay.
Dichromate.
Dichromate, not potassium manganate. Dichromate. Okay, oxidation test. Okay, so the difference between Lucas test and oxidation test is the other way around. So if Lucas test, Lucas reagent is a mixture of a concentrated sulfuric acid and zinc chloride. We mix this one, and then only we mix with your, first we prepare this Lucas reagent first in the test tube. Okay, prepare the Lucas reagent in the test tube, and then only you test with your whatever sample that you have. Okay, so we need to observe the rate of reaction. If tertiary plus Lucas reagent, it will immediately form cloudy haloalkanes. Whatever lah, it doesn't matter. In observation, you don't know it is haloalkanes. As long as immediately form cloudy solution, that means it's a tertiary alcohol. But when it is oxidation, it is tertiary alcohol will not react, right?
Yeah.
Okay, but then for Lucas, it reacts immediately to form cloudy solution. For secondary alcohol and Lucas reagent, it takes about 5 to 10 minutes to form cloudy solution. Okay, so it takes a longer time. When it is more than 50 minutes, that means it's a primary alcohol, because you need to heat it up. So when you have waited for 15 minutes for the clouds to come, that means it is primary lah. So to confirm that it is primary, so what you do? You do the oxidation test. Yes. Okay, because the oxidation test, immediately a primary alcohol, you add with the potassium dichromate, what you get? Color change? Color
Orange to green.
Orange to green. Green.
Yes. Orange to green. Okay. To confirm it is a primary alcohol. Macam tu lah. That is one test. Not yet. Not finished yet. Okay. Because I'm not writing oxidation because we have learned yesterday. So that's why I don't want to put it there. I want you to recall what you have learned yesterday. Because oxidation reaction is also a test for the alcohol. Okay. To differentiate between primary, secondary and tertiary alcohol. Okay.
Okay.
Alright. Okay. Another test is the iodoform test. Okay. We call it as iodoform test. So what is iodoform test? The iodine solution is added to small amount of alcohol followed by just enough sodium hydroxide solution to remove the color of iodine. So iodoform meaning is the triiodomethane that is formed. The positive result shows the pale yellow precipitate. We can put as pale yellow. Sekejap Dia yellow Oh, is it orange? Ya, betul lah. Yellow solid or yellow crystal or yellow PPT. Okay. Either way lah. It's yellow lah. Yellow. Okay, yellow. Orange is 240 NP. Aku dah confused. Okay, so iodoform. So when it is a positive test, meaning you get this, the yellow PPT or yellow solid. Okay. So what kind of alcohol that will give you this positive test? This one. You have this carbon, hydroxyl carbon. This carbon we call as hydroxyl carbon. Okay, can you see my cursor?
Yes.
Or should I use my pen? Sana. Okay. So this is your hydroxyl carbon. Okay, because hydroxyl carbon, because this carbon is attached to OH, right? So this carbon, this hydroxyl carbon has this CH3 group, not alkyl group, not alkyl group, CH3 group. These can be hydrogen atom or it can be any hydrocarbon. We don't care. These we don't care. The one that we care about is this CH3. This one you have to focus on. This hydroxyl carbon has CH3 here. Then only it will give you a positive result for iodoform test. Do you understand? I'll give you an example lah. Okay, so this one also the iodoform, the reagent for this test is iodine. Ni iodine solution in sodium hydroxide. Okay, sometimes they just put in, they don't in question, sometimes they don't say that they are doing iodoform test. It's just that they say that this alcohol, compound A is an alcohol. So when you test with iodine in sodium hydroxide, the test gives this pale yellow precipitate. So you should understand that that is an iodoform test. Okay, that's the meaning of what I'm saying here. Okay, if nothing happens in cold, then it may be necessary to warm the mixture gently, very slightly warm lah, not heated vigorously. Okay, so the most important thing is that you have to focus on this group. Okay, this one, the hydroxyl carbon, what is attached to? When you have this CH3, then it will give a positive result. So and it must have this hydrogen. Okay, sorry, the hydroxyl carbon must have hydrogen and must have this CH3. This doesn't give that much effect lah, whether it is hydrogen or it is an alkyl group whatsoever, it doesn't matter as long as you have these two. Okay, as an example, if belum lah, apa pasal kau pergi pula? Okay, if ethanol meaning this is H kan? If it is ethanol, so this is H. Okay, so ethanol we give a positive test to this iodoform test, meaning ethanol will give yellow PPT. Okay, so if R is alkyl group, let's say this is another CH3. Okay, that means this one is secondary alcohol. So it is still, the most important thing is that this carbon has CH3 and it has hydrogen here. So this one will also positive test to iodoform. But tertiary will give a negative test for iodoform, because tertiary we have R here and this one also R. Again, we have CH3, let's say we have CH3 here, we have CH3 here. So this one will give negative because there is no hydrogen atom attached to this hydroxyl carbon. It's just like oxidation. Remember oxidation, when you don't have hydrogen on the hydroxyl carbon, there is no oxidation that occurs. Same thing for iodoform, because iodoform test is a type of oxidation that occurs.
Teacher, I don't understand the second sentence.
This one.
If R is a alkyl group.
If R is alkyl group, meaning let's say you want to make R is ethyl. You have R is CH2, CH3 lah.
Mm-hmm.
So this carbon becomes secondary carbon kan?
Mm-hmm.
So this is the secondary alcohol. If this is CH2, CH3, meaning this is 2-butanol.
Okay.
So this is 2-butanol. So it is a secondary alcohol. So this OH has this CH3.
Okay.
It doesn't matter lah what your R is, as long as you have this CH3. So it will give you a positive to this iodoform test.
So if it is positive, it's either ethanol or a secondary alcohol lah.
Yes, but secondary alcohol, secondary alcohol, yes.
Okay.
Tertiary alcohol, no. But then, okay, let's say you have a secondary alcohol also, but then this is CH2, CH3, and this also CH2, CH3.
Oh,
So will it give a positive test or is it going to be a negative test?
negative.
Yes, because you don't have CH3 there. Get it?
Okay. Okay.
Must be methyl.
Yes, must be methyl. Okay. Okay. So dah tak nak gerak pula.
Alright.
Okay, so this is actually what happened. La ilaha illallah. Come back. So this is actually what happened in the process of getting this. This is your triiodomethane. This is your triiodomethane, okay? Your triiodomethane is what gives the name for this test, the iodoform test. This triiodomethane. So this is the process that your alcohol goes through when we add iodine in sodium hydroxide. So actually there is a few steps like oxidation lah and all that, and so I've just simplified simplified the whole process from alcohol, and then it becomes maybe ketone or maybe aldehyde. Not ketone, it must be aldehyde. And then it becomes like this I3, and then it become this triiodomethane. This triiodomethane is the one that we give you that yellow PPT. Yes, this one. Okay, and this is usually is in the form of carboxylate salts or carboxylate ion. Okay, so usually it is dissolved in water. So the whole process is, the most important thing is these two lah. Whatever is in between two, not really important, but this is very important. Okay, the final product. Okay, as an example here, okay, we have let's say we have the here 2-propanol. Okay, 2-propanol. So this is your hydroxyl carbon. Okay, this is your hydroxyl carbon. So you need to focus on this hydroxyl carbon. What is this your hydroxyl carbon is attached to? So it is attached to 1CH3. So when it is attached to 1CH3, so it will give you iodoform. So that means it will give you yellow PPT. My minus is terbalik. How come the minus is here? The minus is supposed to be here. Terbalik pula. The minus is supposed to be here lah, not there. Ayo. Okay, another example here. Aldehyde also. And this is not, the iodoform test is not only for alcohol. Next week when you learn this aldehyde and ketone, okay, aldehyde will also give you a positive test for alcohol because you need to focus on the carbonyl carbon. Focus on the carbonyl carbon here. This is your carbonyl carbon, right? So what is next to this carbonyl carbon, which is CH3? And then of course aldehyde has this hydrogen, so it has CH3 and it has hydrogen. So will obey the rules that you have the CH3 and you have this hydrogen, so it will give you iodoform. Okay, so this one will give you a positive test to the iodoform test. So this is how you write the reagent for iodoform, like this only. It is possible for you to write iodine in sodium hydroxide, or it can be iodine / sodium hydroxide, also possible. And then some people, they will label it warm, not heat, not the triangle, but it just warm. So that's why I don't add in, because warming is not that much needed lah.
Yang saya terus dek.
Okay, done. Yeah. Okay.
Jadi 45 banyak, tahun tu 24 je takkan 24 tu nak ada 20 juga. Jadi macam makan tu, kalau kita kesana sikit, jadi jauh sangat lagi. Bismillah.
So
Okay.
this iodoform test, primary, secondary alcohol and aldehyde will give positive result.
Not all aldehyde. You need to look at the aldehyde lah. Let's say for example, if you have butanal.
Okay.
Butanal. Is there any CH3 next to the carbonyl? Carbonyl carbon?
No.
No, so it will not.
Oh, okay. Right.
Okay.
Teacher, does all secondary alcohols give positive
No.
iodoform?
No, not all. Just now I gave you the example. Let's say you have, let's say this is your CH2, CH3, for example. Your ethyl is also ethyl. It is also secondary alcohol, isn't it?
Yeah.
Your R is ethyl, CH2, CH3. Okay, let me write. Sekejap. Pen. Okay, so this is your carbon, your oxygen, this is your not using my pen. Okay, let's say this is your CH3, CH2. Huh? CH2. Okay, so this is also ethyl. Same thing here. So will it, this is a secondary alcohol, isn't it? Oh, H then.
Yes.
Yes, secondary.
Secondary alcohol, right? This ethyl, this ethyl. This is also secondary alcohol, but will it
No
give a
methyl.
positive?
No, because no methyl.
Yeah, there is no methyl. So it will not give you, a positive test to iodoform. Okay. Hmm. Pula gerak. Okay. So this one, alright. Exercise. Try. Which one will give you a positive iodomethane reaction?
B.
B.
Copy lah.
Oh,
Oh, kopi eh?
You want to copy, okay lah. Done.
Screenshot je.
Ah? Screenshot.
Screenshot je.
As long as when the question come out, you know how to answer. Okay, so have you got the answer?
Yes.
So what is the answer?
B.
B,
D.
D,
G. B. D. G.
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 D.
Bergedil.
D.
Kakak kat bergedil. H not.
H. Tertiary.
Yes, yes.
H tertiary, right? Oh, H no.
Tertiary cannot. So H
Tertiary.
cannot.
Okay. E,
G.
No.
why not? There's
No.
G together.
Carbon.
No.
There's only one carbon. Yeah. Okay, so the answer is B, D, and G.
G.
Okay? Yeah. D I already given you the example, what? Actually betul. Apa that B also I think tak. Okay lah.
B. No.
A already given you the example, right? It is not.
Yes.
Okay, so we are finished with the alcohol for today. Yeah, but I have questions for you, but I'm still editing the questions, so I will give you later today for your tutorial. Okay, for your tutorial of, because I haven't given you the tutorial for alkenes and alkene and also haloalkene. So I will give you by today before this evening. Okay, so for your homework for the weekend. So tomorrow,
Tomorrow.
Tomorrow Friday.
Yeah, tomorrow Friday.
Friday prayer.
Friday prayer. Next week.
Next week also got Friday je. No worries.
every week also got Friday. Just panjang umur.
Allah.
Panjang umur that every week also got Friday. So tomorrow, because the exercise I just giving you today, is there any exercise that I haven't discussed? Alkin discussed already. Kan? The one exercise I gave you.
Yes.
Discussed already. So there is no exercise that we haven't discussed. So we are going to continue with aldehydes and ketones. Here go.
Yeah.
Aldehydes and ketones. The carbonic compound, aldehyde and ketones. Okay, so I need to move very, very fast. So those who can catch up, please do so. Do catch up with the lessons, because when you come back next week,
Oh man.
the week after that, we are going to do practical.
Yeah.
No lecture je.
No lecture.
Got lah.
Oh, lecture.
We have 8 periods a week.
Yeah.
We have 8 periods a week. So
I have a
4
question,
periods. Wait. 4 periods will be for your practical. So 4 periods will be for 2 periods for lecture and another 2 periods, because there's a lot of tutorial that we haven't discussed. So 2 more periods for tutorial. The single one will be tutorial lah.
Okay.
Okay, Lokman, you want to ask me what?
Arif.
Oh, not me.
Oh, Arif. Yes.
Sure. Can you say that we're going to have classes from the asrama kan? So like when exactly would that be? Like bila lecture biasa ke, or like I don't know. Like
During the class hours, because we have to limit those people in the academic building. We have to limit that.
So when do we start our?
but it won't be like every lecture lah kan?
No.
I
It
see.
won't be for every lecture. There will be a schedule that
I
who
see.
will be doing online, who will be doing face to face. But for sure, in a week there will be twice practical when you come back.
Yeah.
Practical will be on. So we have already scheduled. Your practical will be on Tuesday and also on Thursday.
Wah.
I can't wait.
Can't wait.
Hey,
Oh,
can't
wow.
wait.
Yeah.
Okay, Lokman, video.
Okay, any more question? And make sure you all don't come in the morning, eh?
Don't come in the morning. Oh yeah.
When you
Two,
register.
Oh,
Because,
okay.
in the morning is for the first year students, your friends, not yours.
Junior.
Juniors.
Okay, yes.
I want to tell them to make me tea.
For the juniors, okay? So don't come in the morning. You will not be entertained. You come in the afternoon. Alright. So I think that's all. I will give you the questions in the Google Classroom. Alright.
Right.
And anyway, when you come back, you all are going to have your own laptop, right?
Yeah. Yes.
You all are going to have your own laptops, and so I can give you any time for the class kit if you are using this online, kan?
Yeah, but then
Using data.
Wi-Fi lah, teacher.
Wi-Fi,
Yeah.
no.
I have laptop but no Wi-Fi.
We need to be at the staff room je.
Wah.
Our Wi-Fi also not that good lah.
In that case, we can have the class.
Okay.
We keep the class lah.
No class kick lah. Then I kick you in the class lah.
Tarik pun.
Okay lah. Okay. Let me do my work. Then I'll give you the questions. Okay.
Okay, teacher.
Alright. Thank you.
Alright, teacher. Bye,
Okay.
teacher.
Assalamualaikum.
Thank you, teacher.
Okay. Bye.
Bye, teacher.